I will introduce my research content from the following four aspects. The first is research background and significance. Time reversal is one of the main contents of my research, and the other is wireless power communication network. Arena after referred to as WPCN. WPCN is a kind of wireless energy transmission technology, which can solve the problems of inconvenient battery replacement and energy storage of wireless devices in the process of wireless communication and realize the self-sustainable of wireless devices. However, as the RF signal strength decrease with the increase of transmission distance, the network capacity is very limited by the network size. Therefore, how to improve the system network capacity is a challenge facing WPCN. It is also of great significance for future wireless communication system to further improve system performance by studying efficient resources management and allocation scheme of WPCN. At the same time, with the continuous complexity of WPCN structure and diversification of application scenarios, interference will inevitably occur, and how to suppress interference to maintain good performance of the system also needs further research. Time reversal herena after referred to as TR is a pre-processing technique which inverts the signal in the time domain, equivalent to phase conjunction of signal in the frequency domain. The biggest characteristic of TR is its space-time focusing. By using channel reciprocity, TR can make the sent signals converge at the target receiver at the same time, which can effectively resist channel fading and reduce interference while improving the received signal power intensity, thus improving the system performance. My main work is as follows. Firstly, the TR-WPCN model is constructed by introducing time reversal technology in the WPCN of the relay to counter interference. Then, the optimization objective is sent to maximize the throughput of the system by allocating time. As shown in Figure 1, this paper considers a Dow-Hope WPCN consisting of one HAP, one energy constrained relay node and K terminals. The hybrid access point, hereinafter referred to as HAP, and the relay node are equipped with N antennas, and the terminal is equipped with the signal antenna. The transmission The transmission process of the whole system is completed by three processes. Downlink wireless energy translation parameter referred as to WET. Time reversal detection and time reversal detection and uplink WIT, as shown in figure 1A. The HAP transmits energy to the relay node and the terminal node in the downlink WET phase. And the relay node transmits detection signal detection channel state information to different terminals in the time reversal detection phase. The channel gains between the HAP to the relay node and to the terminal node K are defined as uppercase H and the lowercase letters HHK. The uplink wireless information translation parameter after referred to as WIT process is divided into two stages, as shown in figure 1B. After the terminal node records the detected status information and the performance PR operation. In the first stage of uplink WIT, the terminal node uses the energy stored in the downlink WET stage to send the information to the relay node. And in the second stage of uplink WIT, the relay centrally processes the received signal and forward it to the HAP. Define the channel gain from the relay node to the terminal node K as lowercase letters HRK. Considering the frame structure of the Dow-Hope WPCN with K terminals shown in figure 2, one frame is divided into 4 time slots. In the first time duration tau 0, HAP broadcasts an energy signal to the relay and all terminal nodes in order to provide energy for their upcoming uplink transmission tasks. In the second time duration tau TR, firstly, the relay node sends detection signals to different terminals to obtain discrete channel impulse response. Then, each terminal records the discrete channel impulse response and inverts it in the time domain. After receiving the energy signal to supplement the battery, the terminal nodes use the collected energy in the third time duration tau 1 to convolute the information signal to be transmitted with the inverted discrete channel impulse response, and then sends it to the multi-antenna relay nodes through SDMA. In the fourth time duration tau 2, the relay node uses the energy stored in the downlink WET phase to forward the descended information to the HAP. What this page shows is in the WET phase. HAP sends energy beforms to the free battery multi-antenna relay and all users at the same time. The signal received by the relay nodes and the terminal is following. This page shows is what this page shows is in the this page shows is TR phase. The relay nodes and the terminal nodes receive the energy signal. The relay sends the detection signal to the terminal. The terminal inverts the discrete channel impulse response obtained by detection in the time domain to obtain the equivalent channel response, and normalizes it as a channel signature waveform. Its terminal transmits information through channels with different channel signatures, and effectively suppresses interference by adjusting the parameters of channel signatures. The normalized channel is signature waveform after TR processing is following. 这个然后就是上页。This page show is in the WIT phase in time slot tau 1. According to transmission characteristics, the channel from the terminal to the relay node is regarded as a multi-access channel, so its capacity can be expressed by following formula. 这个 This page show is in the time slot tau 2. The relay node decodes the message received during tau 1 and sends it to HAP through the MIMO channel. Its capacity following. This page show is the follow of the overall scheme. One is download the WT phase, 2 is TR phase, 3 is uplink WIT phase. 就是 this combination results. The specific simulation analysis is as follows. For the WPCN, considering the double distance problem of the network itself, and the interference will affect the system performance by introducing relay and combining TR. This paper joint optimizes the resources allocation problems such as the transmission time of each stage of the network, the transmission power of HAP, and the transmission power of relay, in order to maximize the total throughput of the system. According to the module established by the proposed problem, the non-convex problem is transformed into an equivalent convex problem by introducing relaxation variables and auxiliary variables. Then the convex problem is divided into two sub-problems to obtain the sub-optimal solution of the original problem. The simulation results show that the proposed scheme can suppress the interference and improve the system performance on the basis of effectively alleviating the double near-far problem. The WPCN system has broad applications prospects and can be used in various sensor networks. Future research can allocate and optimize resources for multi-antenna HAP and multi-user complex multi-cell environments and vehicle networking environments. The focusing intensity of time reversal technology depends on channel estimation. When there is an error in channel estimation, it will affect affect the focusing of time reversal. The scheme of this paper assumes that the channel state information is perfect, but in practice, the channel estimation will be affected by many factors in the various environment. Therefore, when there is an error in channel estimation, the performance of the system will be affected. Okay, this is my report.